Just talking briefly about genetic groups. So in the genetic evaluation, if we're making progress, then genetic merit will be increasing over time. It's a given. So we know the New Zealand sheep industry may be making a good job of genetic progress, and this is the Sil-Ace genetic trends graphs, and both the terminal sire and dual purpose flocks have increased in genetic merit by about 1,000 cents or $10 since 1995. Currently, animals which have got no pedigree links are grouped with base animals. So they're actually brought back to the base, the start of the analysis. And these sort of animals include, so the animals with no pedigree links, these are animals from, such as outside sires, so you bring in a sire into your evaluation that doesn't have any background flock information. Screened in ewes that have got no pedigrees. Animals that are born in your flock that you don't know the sire or dam of. And also new flocks that don't have the depth of pedigree going back. So these animals will be treated as the animals at the start of the genetic evaluation. So if we're now in 2015, where the average merit of your flock's around 1,000, and these animals that are brought in, and you think you've brought in some pretty good animals, but these animals will be treated the same as the base animals, so they'll actually be down at the start of the analysis, the 1995 year. So they're severely penalised. And this is one of the things that frustrates breeders. They bring in an outside sire, they've paid good money for it, or they've selected it on high genetic merit, they bring it into their flock, and it performs very poorly because there's no information on its background and it's treated like a base animal. One way to overcome this in analysis is to form genetic groups. So instead of bringing an animal in and saying it belongs to the base population, you bring it in and you form a separate group and let that group find its level within the analysis. And so if you brought in an animal that's good in 2015, you'd want that animal to have a genetic group that was similar to the 2015 animals in your flock. There are some issues with forming genetic groups. It means it's not just a trivial exercise. You want to have groups that are large enough to enable accurate estimation of these. If you just have one or two animals without pedigree and they happen to have high weaning weights, then they will be overestimated in terms of what their merit is. So you need a group large enough to be able to say what the average merit of that group is. You want the groups to be composed of similar animals. If I said that if I had a crossbreed analysis and I said all the animals born in 2015 without pedigree, just throw in everything, we'll throw in Merinos and Romneys and Kirkworths, then again you wouldn't get a good estimate of the genetic merit of that genetic group. And we also need information on those animals on which to be able to benchmark the production level of that group. A group of animals needs to have weaning weights or fleece weights or other information that actually lets you say what the production level of that group is. You can't just bring in animals with no information and expect the analysis to be able to handle them. So genetic groups, the work we've been doing in the national evaluation, we're working towards fitting genetic groups within flock and year. And where there are insufficient animals in a flock and year combination to form a genetic group accurately, we'll be looking for animals of a similar breed. So you look at the breed composition and those animals will be grouped with other animals that are of similar breed. So that's to get an idea of the average merit of animals that have no pedigree information of their own. And what does this mean? I've got, I think, quite a tidy example of what this does. This is the genetic gains for a flock that routinely screens in ewes. And under the current analysis on the left, that's the genetic trends that have. It's the genetic trends that they get from the current analysis. When we fit genetic groups, the genetic trends graph on the right shows the true value of the flock. So instead of going from a genetic trend from 1 to 1.5 on the left, the true genetic trend for weaning weight is from 1 has gone up to 5 in the last 20 years. So that's quite an improvement. Makes the people more happy about what they're seeing in their flock as to what the breeding values are achieving. Similarly for NLB, it's an increase in the estimated genetic merit for that flock when you account for screened in animals correctly. If I fit genetic groups, this flock with a large number of screened in ewes, we're fitting genetic groups each year, and this is the average genetic group values. So it's saying that over time, the animals they're screening in are improving. So instead of taking those back to the base level and reducing the apparent genetic merit, those animals are able to find their own value. This is for weaning weight, and similarly for NLB, those animals are screened and are of better merit than the base animals over time. One interesting observation is in this flock, the screening in is done on the basis of having had twins. So on the basis of their supposed merit for NLB, and the genetic trends, the genetic groups values in the red compared to the rest of the flock in the blue. The genetic groups values are similar to what the rest of the flock is, so you could say this guy is doing a reasonable job on his screening in, but when you look at the value of the genetic groups for weaning weight, it's not, the screened in animals have poorer genetic merit for weaning weight. So in conclusion, fitting genetic groups improves the accuracy of the estimated breeding values, especially for the animals with no pedigree, but the specification of the genetic groups to be fitted is important. And we've been doing quite a bit of work looking at the effects of different genetic groups to make sure we get it right in the analysis.